Yes, I'm our teacher Olimboka Sajuga Masame. Welcome to Olimboka Physics. Let us take a look on concept of refracting telescope. We use this question from TIE exercise 4.3 question 5 to just see how the refracting telescope is operating. Okay, the question states that an observatory telescope has an objective length of focal length 14 meter. Suppose an eyepiece of focal length 2 centimeter is used. Part A. What is angular magnification of the telescope? If this telescope is used to view the moon, what is the diameter of the moon's image formed by the objective lens? The diameter of the moon is 3.48 times 10 to the power 6 meter, and the radius of the lunar orbit is 3.8 times 10 to the power 8 meter. Let us see the constructions for these scenarios, this question below. This is your Earth, and this is your telescope on the surface. It's got a lens L, and this is eyepiece, and this is objective lens, and this place is where eye is closely to the eyepiece, and this is for case of aided eyes, and for unaided eyes is where eyes at this point O, and this is our moon, and this is a parallel rays of light that won't incident on the point O, but the tangent rays of light are the ones that incident at point O that appears to come parallel to the observer's eyes, as you can see to the internal part of the diagrams of this telescope. Okay, this is our lunar orbit. This is our lunar orbit, and this is the radius of the moon, that's CF or CE or CE dash. And this is the radius of the lunar orbit, capital R. That is radius of the moon is small r, and for lunar orbit is capital R from the S. That is our adjacent here now. This is adjacent, and this now is hypotenuse, sorry, and this now is adjacent. Remember, this theta is visual subtended angle at an objective lens O. Let us just take a close look on the internal part of this refracting telescope. Okay, this is a parallel rays from the moon that form a first image here. Remember, the features of refracting telescope is in such a way that the objective lens is relatively larger compared to eyepiece. This is in order to accumulate a lot of more light rays from the distant object, because the main functions of refracting telescope is getting a close view of the far distant object on the skies. Okay, and this is uses for a case of infinity images. The final image is at infinities, and this is a normal use of refracting telescope. Normal use of refracting telescope, the final image must be at infinity, and therefore if the final image must be at infinity, we say that the eye is an accommodated and is undergoing the least strains or very relaxedly. Okay, as previously explained on the simple microscope. Okay, the top point of the final image is, as you can see here. This is the constructed lines as usual. You must draw first this constructed line so that it can direct you where the refracted lines will head backwards. Okay. Remember, the visual angle of subtended with unaided eyes is equal to that of objective length. Remember that we assume that this length L A plus R is very small. It is approximate equal, to the just radius R, because this is a very small length compared to the distance from the moon to the earth. Therefore, when observer views through the eyepiece is the same as he or she views with unaided eyes at the objective lens O. Therefore, the angle theta subtended on the object is the same as angle subtended on the objective lens, because with unaided eyes the object is still at infinity, and therefore the angle will be the same as theta. And with aided eyes or with telescope, still the angle at objective lens will be the same as that of the unaided eye. Okay, after taking a look at that assumptions, let us do some simple mathematics here, and you may follow these explanations here below, so that you can see how we reached at that assumption. Okay, our theta now, from this case, this h is h for image 1, that will act as image for that will share the angle theta dash, and at the same time will share the angle theta of objective lens. Now let us consider angle theta for objective lens, which is opposite to adjacent. Adjacent here is focal length of objective lens, and the theta dash subtended at an eyepiece for the final image now is also shared with the h of this first image, and which is opposite, and this adjacent is focal length of eyepiece, as you can see here. Then we refer the total angular magnification for refracting telescope is equal to angle subtended at image and angle subtended at object. Then our h is common, then it's cancelled out. As you can see, the h is this one, but shared with this part, this angle theta and this angle theta dash. Okay, now we have the ratio of focal length of objective lens to focal length of eyepiece, that is total angular magnification. So while the length L for this case, separations of objective lens to eyepiece is equal to the sum of focal length of objective lens plus focal length of eyepiece for the conditions of an image to be formed at infinity, or for the normal uses of refracting telescope. Remember, the image from infinity must form at a focal length of objective lens, and this focal length of objective lens coincides the focal length of eyepiece. The arrangement must obey this coincidence, so that the final image must be at infinity for normal operations of a refracting telescope. Okay, for the case of these questions, we have sine theta, which is equal to CE, which is equal to CE, which is opposite to adjacent C dash O, and which is equal to small radius r to this is sine, sorry, which is equal to CO, which is hypotenuse, CO, which is r, sorry, not adjacent, CO is r, and from figure B, and this figure B now we will have tan theta. Here's the relationship is tan theta, which is opposite to hypotenuse of objective lens, and this is radius r dash, this which we take it instead of h of the first image. And from there we just assume for a small angle, we know that sine theta is equal to tan theta for a small angle and is equal to theta. Then for these comparisons of these two expressions for sine and tan, we can have be able to find the radius dash, the image of the radius of the moon, as you can see here. And as the diameter, we just twice the radius, and then we substitute to the formula, and we get the second formula as this one for the case of diameter. Then we substitute the data that we have been given, and we arrive into the answer into meter, and now approximate into centimeter is 12.82 centimeter. Okay, remember this focal length of objective lens is 14 meter. Therefore, For unusual uses of telescope, for unusual uses of telescopes, the final image must be formed at near point. This, remember, is unusual way of using the refracting telescope. Now, our eyes here is we said that our eyes here is accommodated and mostly strained or not relaxed. Therefore, at this case is image formed at near point instead of far points. Okay, now the diagrams that indicate this case is, as you can see here below, this is our eyes. This is our constructed line. You must draw the first. After drawing this refracted line that crossing the this principal axis, you must also draw this solid line so that it can guide us to indicate the final image at a distance d. Then this refracted rays is just constructed backwards so that we'll meet this constructed line, which is a dark just the dark line, the black line. The distance from this eyepiece to where image formed is a normal distance, distinct of visions. That's the distance d. And remember, the image formed is visual, and it is in the same orientation with the object with h, and it is formed at a certain distance close to eyepiece, certain distance close to eyepiece, and this distance is at a focal point of the objective lens. Remember, for the case of distant object, the image formed at a focal point of the objective lens, or of the lens that is receiving the parallel rays. As you can see here, this is the first image, and this is a focal length from here to here of eyepiece, and our objective distance now for image 1 will be equal to UE for eyepiece, and now the image distance here is equal to that of focal length of objective length for this image 1. This is separations L. You may follow these dimensions so that you can also be able to draw the arrangement, as you can see here. And let us see how we can get the angular magnifications of a refracting telescope when a final image formed at a near point is that we refer as it is not at its normal adjustment. Okay, for theta, this theta shared with this h first image, and also this theta dash for final image also shared with this first image h. This is h, which is the opposite, and its adjacent is equal to focal length of objective lens. Now for angle theta is equal to h to focal length of objective lens, and theta dash, now remember this is tan relations, and this is opposite for theta dash, and this is adjacent, which is object distance for eyepiece. And then here we refer as for small angles. Now for total angular magnification, we know is equal to ratio of subtended angle for aided eyes to unaided eyes. Then after taking the ratio, we constantly add the h. H, remember, is common. This h is common for this side and this side, and then we remain with a focal length of objective lens divided by objective distance at eyepiece. Okay, for the final image at D, now we know that D here is negative because this is a visual, and for L dot H is equal to 25 centimeter. Now our focal length for eyepiece is positive because it's convex lens, and now we refer the thin lens formula so that we can find the value of image distance at the eyepiece, and then we place the value of D, which is equal to negative, at these relations so that we can end this negative and we remain with positive and the relation as you can see here. And then we substitute this into this relation for angular magnification of a refracting telescope for a near point final image to be formed. then we'll have the expression as you can see here after a further simplifications. Then to prove these relations is just when we substitute d, which is equal to infinity for the case of normal uses of refracting telescope here. Now we remain with the ratio of focal length of objective lens to focal length of eyepiece. Remember, this negative is there because the final image is inverted with respect to the initial to the object. Okay, thanks for watching. Please like, share, comment. Don't forget to subscribe this channel for more videos like this one. Thank you.